Hello guys, welcome to the last presentation for paper 2 mathematics exam preparation series. Yes, you've made it to this far, you've made it to this point, and it is indeed something worthy of celebration after watching this video and learning what I have in store, and ensuring that indeed you just give yourself that pat on the back and say, I made it and I'm ready to attack paper 1 and paper 2 exams that are before me and achieve those excellent results. All right, so yeah, let us wrap up with question 13, and it is in two parts, A and B. All right, so let us take a look at question 13a. Here it is. Okay, so this is a common question where you are asked to investigate the relationship between the sum of the radii as well as the distance between the centers of the circles. All right, and depending on what you get, you will say the circles either touch or they intersect or they just don't make any contact. All right, so let us see. This side we have the equation in standard format, and we can read off the coordinates of the center as 3 and 4. This side is not in standard format. The square is complete there, but it is not complete there. Constant is missing for the variable x. So half of 2 is 1. So square of 1 is 1. So we add 1 both sides to have 2x plus 1. And we still have that, but we can just reduce it, to the standard format for this part of the equation, and this is now complete, giving us x plus 1 square plus y minus 1 square equal to 1. And let us read off now the coordinates of the center is -1 and 1. Good stuff. Okay, now can we get the distance? Yes, we can. Between centers is the square root of what? -1 minus 3 all square plus 1 minus 4 all square. This gives us 16 plus 9 giving us 25. Square root of 25 is 5. So the distance there is 5 units. Okay, let us compare now with the radii. Now this is r squared, this is r squared. You need to add up the radii and figure out if it is greater, equal to, or less than 5. Okay, so r1 plus r2, I'll call this circle 1, that will be circle 2. So radius 1 and radius 2, square root of 4, that will be equal to 3, and definitely it is less than 5, meaning that definitely the circles do not make any contact. All right, so therefore the circles do not make any contact. Okay, so that definitely answers the question, where we are saying that we support the teacher, where the claim is that the play areas of the two toddlers will never touch. Okay, so this takes care of part A of question 13a. Let us go to 13b. This is how it looks like. Right, so we are asked to find the perimeter of rectangle ABCD. Inquiry: what are the properties of a rectangle? Opposite sides are equal. Okay, meaning that AB is equal to CD and CB is equal to AD there. Okay, we don't need to go into angles because we are only talking about perimeter in this case. Now, what are we given? We are given the area of a quarter circle. Okay, FEG. The area here is given as 8 pi units square. Okay, we are told that the circle has a radius of 2 units. okay, and it is centered at A and touches the y and x axis, meaning that they are tangents to the circle, okay. So that would mean that that length here from the origin is 2 units, that length there from the origin is 2 units, making the center to have the coordinates of 2 and 2, okay, and that is where we are, okay. So how do we then navigate to the solution? We will need to find FB. FB represents the radius of the quarter circle, okay. So we know that the area of a circle is equal to pi r squared. So for a quarter circle, it's this expression divided by 4. So we have pi r squared over 4 is equal to 8 pi. Okay, division both sides by pi over 4 gives us r squared is equal to what? 32. And therefore r, which represents what? This length right there. FB is equal to the square root of 32. So there we go. We have square root of 32 for FB. So got that. If we can find AF and subtract the 2, we'll find AB. We link it to CD. And by theorem of Pythagoras, we're given the square root of 11 there as the length of AC. We can find AD or BC and then obviously multiply by 2 to get the other side as well. So basically that is where we are. So how can we find AB? We have coordinates of A, we have coordinates of F. Can we find the distance then? Yes. So AF is equal to the square root of 5 minus 2 all square plus negative 1 minus 2 all square. Okay. So this gives us 9 plus 9, giving us a square root of 18. Good. So this guy right here, the length is square root of 18. Okay. So therefore, AB is equal to the square root of 32 minus the square root of 18. That will be the length of AB. Can we find a simpler expression for it? Let us see. Yes, it gives us square root of 2. So this is square root of 2. So AB is square root of 2, meaning that CD is also square root of 2. Okay, definitely there are 90-degree angles, hence I was talking about theorem of Pythagoras that can come into play here. So what do we know? BC will be square root of 11 square minus square root of 2 square. So by Pythagoras, BC is the square root of 11 minus 2, giving us square root of 9, giving us 3. So that is 3, meaning that this side is also equal to 3. Do we have all the 4 sides? Therefore, perimeter of rectangle ABCD is equal to 3 plus 3 plus root 2 plus root 2, giving us 6 plus 2 root 2 what? Units. Guys, this takes care of question 13 and will take care of the entire paper 2. So this is it, and thank you very much for watching. Thank you very much for tuning in and being consistently a subscriber as well as a viewer of the recent uploads that you are aware of. So keep up doing that, because definitely you keep benefiting the more you watch, the more you interact with me on the channel. And I believe this was helpful for you in terms of your exam preparation, and I wish you well. I wish you excellence in mathematics. So thank you so much. I'm now going to work on some physical science exam prep material as well, so be on the lookout for that. And I believe that I will see you that side. If you are also a physics chemistry student, let us have fun that side as well. In the meantime, keep well and thank you. Shap shap.